thanks very much for ProEconomy for inviting me to give this presentation. I'm Warren Bradshaw. I was the Water Safety Officer for the Highland Council, and I've now moved to Gordonstoun Schools as the Head of Facilities. I was part of a team that worked for the council that rolled out an industrial attempt at the Internet of Things remote monitoring technology, monitoring water temperatures. And when initially we started to look at the IoT, Internet of Things remote monitoring technology, we had a very basic understanding of what we wanted to achieve. It was to take a temperature. The principal driver was to increase compliance, lower costs, reduce carbon emissions, and decrease our resource interaction. But actually, that journey is much more, as it's not just about taking a temperature every 15 minutes. It's about what does that mean and how do we quantify risks without a complete picture. How do we enlarge our data story and visualize risks across multiple data sets? Within the council, when we first started rolling out the IoT, we had a piece of software and we just looked at these temperatures. But then we started to realize that we needed to bring together other data, such as the risk assessment. Using live data from IoT alone can lead to unpredictable data decisions, where information sources need to be interrogated to make sound decisions. Like, do I turn up the clarifier based on this temperature? Is the risk assessment correct? When we have large data sets, what other business decisions can we make? Such as, is my clarifier on too high? Can I turn it down from 72 degrees to 65? And can I make a saving on energy? Our data journey initially wasn't right, and it needs to be right for your organization. When we had multiple software packages that we had to interrogate with unstructured data sets, then we soon realized that this created a lot of friction for people to make decisions. When looking at technology to resolve a problem, you need to ensure it will solve the problem that you're looking at and not create other dependencies. For example, when we went out and started to buy water monitoring devices, who was going to fit this stuff and maintain the devices? Does the device create another maintenance or other monitoring requirement? When looking at our deliverables for information, you have to stack them. And what we mean by that is that we started to say, well, if we were going to put in place an Internet of Things system, what would we need to do that? So within the IoT stack, we had things like hardware, communications, cloud storage of the data, other data storage issues, such as how do we get that data into another software package, and then the security of that data. And then we had a user stack, and we said, well, what needs to be collected? What is the plan? What's the user experience? And what's the strategy for that data? And how do we process and display it all so that it means something to somebody? You should not underestimate the levels of resources and stakeholders that may be involved in supplying connectivity. And the end solution, the level of complexity involved in what might seem a simple request to adjust or introduce a technology and implement a project may be far more complex than first thought. Put together a project risk register and ensure it's thorough enough to inform the project. Deploy sustainable software architecture, which new, old and existing solutions, all of these can be blended together. This also involves incorporating new and old processes, such as batch data gathering exercises. And that might be just gathering up your risk assessments and putting them somewhere where they're accessible. In most cases, the IoT technology you select cannot simply replace existing systems and processes. Your solution has to be integrated without identifying weaknesses in the instigation of the new technology with your existing systems. Incompatibilities can create implementation issues and confusion. IoT should have the correct data to ensure that it informs the correct risks. If you don't apply the technology in the right way on the systems that you're installing it, then you won't inform the risks. Such as if you were to put a water temperature monitoring device on a random outlet instead of a sentinel outlet, and it was the sentinel outlet that you wanted to monitor, then that in itself creates veracity in the information that you're going to be collecting. All of this data that we end up collecting, this temperature every 15 minutes, well, is it worth something? Can it be used in a different way? And once we have these large pools of data, once we have this big data, what are we going to do with it once we've got it? One of the biggest challenges facing any organisation is recognising the data gathering exercise which is required to utilise different technologies. To fit a water monitoring system, a large amount of data is required to inform the process. You have to understand critical infrastructure that requires monitoring and other at-risk areas within buildings' water systems, which is critical to informing the process. If the system is placed in the wrong areas, then it will not inform the risks, affecting the infrastructure correctly. Good risk assessment is a critical data gathering exercise when applying this technology. Ideally, as-built drawings are required to inform this process. Sometimes we concentrate on big data rather than gathering good data. So you need to make sure that you don't lose sight of this. Data management requires good policies and procedures. How are you going to share this data? The organisation needs to have in place good auditing processes and ensure the IoT is working within its parameters. Batch data has to be confirmed to inform this process. And once you have those policies and procedures in place, you then need to make sure that what you're doing has integrity, it's scalable, and you can exploit the data to make the correct decisions. When undertaking this process on a global scale, information needs to be classified and resources to manage this information need to be detailed and allocated. Batch, semi-real-time and real-time data needs to be integrated into an analysis model, structuring the data for expert analysis. Data veracity due to overwhelming volumes can create bias in interpretation. Organisations can become quick to conclude unless data goes through a process and is enriched for analysis. When entering into data analysis, a number of steps need to be taken to ensure a successful conclusion. We've had people where we've fitted the data and given them access to the software, sit there and say, oh, today my temperatures are high, I need to do something. Or an hour later, my temperatures are low, I need to do something else. That's not efficient use of the data. Goals for the data need to be clearly identified. This can be achieved through policy and business cases. If overwhelming processes are in place, this can overcast the data analysis. You need to ensure that people that are looking at the data are not biased and let the data lead you to the right conclusions. The advantages of managing these processes will make sure that you reduce your manual intervention. For the most part, it will increase high value manual intervention. It allows for proactive approach to water systems management. It increases the integrity of the data being gathered and allows for an improved decision-making process if you get it right. Resource allocation and system management means increased productivity as well. And these are cost benefits that are easily quantifiable. There are also soft cost advantages available, which are harder to quantify, but should not be dismissed, such as conservation in planned preventative maintenance cycles, becoming further informed and more likely to benefit a system, improving reliability. When we initially went out and surveyed 86 buildings for the implementation of the IoT, we started to gather lots of different types of data. One data mining case study that we ran through was we pulled all of the assets that we'd gathered across those 86 buildings. And this equated to 1,200 TNVs, 48 clarifiers, 325 dead lakes, many failing assets, and a lot of areas that were incorrectly piped within these buildings. And we said, well, that's fine. Now we've got all of this data, but actually, can we make some other decisions with it? Can we start to really interrogate this data as to what 1,200 TNVs means? And so we got a contractor involved and said, well, what do 1,200 TNVs mean to you? And essentially, if those valves were put side by side and you were to do a major service on them, it meant 30 weeks worth of work for one person, not including travel time. This equated to about 130 litres of chemicals to sort of disinfect the strainers and the baskets and other bits and pieces. And it also equated to about 6,000 litres of wasted water for servicing. And all the replacement parts that were required came to £33,000. And we said, well, that's fine, but why are we heating water to 60 degrees to cool it down to 40? We started to look at the clarifiers. We had 48 clarifiers across 86 buildings. And once again, talking to the contractors, we worked out that was about 6 weeks worth of work for one person to do a full service, a drain down of that clarifier, clean it, disinfect it, check it, put it all back. That worked out to about 20 litres of chemicals and 24,000 litres of wasted water for carrying out those tasks. $325 dead lakes, which was 8 weeks worth of work for one person to remove them, and that totaled about £32,500 for cutting out those bits of pipe work, and that was only for them doing that. It didn't account for any other sort of remedial works like painting and making good. And then for 675 failing assets, well, we sort of guessed at this at 34 weeks worth of work for one person and about £135,000. And these were all things that were just broken and not working. So annual servicing of 86 buildings, if we were to start to look at doing this, was 30 weeks worth of work for the TNVs, 6 weeks servicing of clarifiers, 12 weeks worth of temperature monitoring, and 6 weeks holiday, plus a form of works plan. And we said, well, 86 buildings, if you multiply that by the Highland Council estate of 1,100 non-domestic premises spread over an area larger than Belgium, well, something's got to change because we don't have enough contractors in-house. And even if we do saturate everywhere with IoT, well, with all of this going wrong, what's the point in taking a temperature? So we had to come up with a bit of a strategy. We had to look to the future. How do we service an estate like this in an organisation of this size? And we did some black box thinking, and we said, well, actually, we need to get rid of the TNVs. We need to get rid of the clarifiers. We need more resources. We need to lower carbon emissions. And we need to lower costs. How are we going to do all of this? So one of the solutions we came up with was to lower the temperatures in the building, removing the scalding risks. And then we could remove the TNVs. But then, well, we created a Legionella risk. We were already using copper silver ionisation from ProEconomy at Lochaber High School, where a refurbishment was done on that school, and due to the refurbishment we were never getting up to temperature across that particular premises. So we put in copper silver ionisation, did regular water monitoring, and the building would never get up to temperature anyway, so we just left it as it was. We eradicated the Legionella problem that was there by using the copper silver ionisation and good flushing, and we used the IoT to monitor the flushing. Most of the Highland Council school estate in the smaller schools, we could use plate heat exchangers. So we could start to remove clarifiers across our estate by putting in instantaneous plate heat exchangers, lowering the temperatures in them down to the 40 degrees and utilising the copper silver ionisation and removing the TNVs, which then made the estate manageable. We would lower the heating costs for the water. It was a space-saving design, so all of a sudden when we're adding bits and pieces onto the schools, we don't need large amount of space to do that. An instantaneous system is a low bacterial risk anyway. And the IoT that we'd put in would monitor flow events and temperature to make sure that the systems were being flushed. And then all we would have to do is to go around and take water samples, which was a lot more manageable. So we implemented the IoT in Lochaber High School. We put in place the copper silver ionisation, and we ran a 1-year trial, which proved successful. We eradicated the Legionella in the building, run low temperatures, and removed the TNVs, which made the site then a lot more easier for us to service. Is this the solution to all of our problems? No, probably not. And I'm sure that there'll be a lot of people out there that disagree with this. But you've got to have the correct application to what you're doing. You need to integrate what you're doing into a risk management plan. And whatever you're doing is going to require checking and PPMs. But you've got to ask yourself, what can we do with the estate that we've got and the resources and the money that we've been given? If we start to think about data gathering exercises in a slightly different way, we could actually not look at making savings, but actually look to start to make money from our data. Organisations that can learn to integrate data into their businesses can decrease their expenses by 49%. It can enhance avenues for innovation by 44%. Approximately 32% of data gathered by organisations can be monetised, with big data gathering businesses worth 118 billion by 2022, with an annual growth rate of 26%. Organisations enhancing their understanding in this field can increase their potential standing in the marketplace. I'm not just talking about the Facebooks and the Googles. I'm talking about local government, NHS, police, fire, all of these organisations that have large estates. If they started to come together, bring together their data sets, they could inform lots of different business decisions and then really start to monetize that big data through collaboration. If the Highland Council started to collaborate effectively with NHS Highlands, maybe with Murray Council and a couple of others, and if we knew how many failing assets we had, then we could go out to the marketplace and through the economies of scale, purchase those assets and reduce costs to those organisations. We can start to inform decisions surrounding designs, what works, what doesn't. How many toilets should you put in a bank of cubicles to make sure that people are going to use them, that the water system gets flushed through? What's the optimum number of wash hand basins to have in a row? What's the best way to fit a valve on a system? All these things can not only help save organisations money, but they can also help make organisations money. Through setting up online targeted procurement, you could essentially have an online system whereby people pay to log on to that system to see what these organisations need. Asset data capture can be logged online with condition ratings, procurement specialists linked to specialist subject matter. Companies can pay to access the data at different levels. And this allows companies to target their sales forces and put offers against projects and programs. Cross-organisation procurement and planning could allow for economic collaboration when purchasing. And this would put organisations at the forefront of making business decisions, essentially saving them money and getting them bigger bang for their buck. By ensuring that we access certain resources, we can then deliver better services at a higher quality. At the moment, there are companies out there that have got artificial intelligence built into their software packages. There is a company that worked for Homeland Security, and essentially they looked online at people's behaviour patterns as they surfed the internet, and they were able to inform Homeland Securities about potential risks that those areas suffered depending on what people were looking up on the internet. They then took that software and started to look at child-based learning, and they run a trial in America where they could start to integrate a child's learning into what they were doing online with their projects and use that same software package to actually put the child through an exam, even though they didn't know they were having an exam, essentially saving on teaching hours, exam hours, and so the children actually got more learning out of it. The point being is that there's lots of technologies out there that are used for other purposes, where we could start to integrate that technology to help us inform better business decisions within the water industry.